Thank you, Yung, and very excited to be here. So what am I working on? This is actually a question that I ask myself a lot. People all know that the field of natural language processing probably have changed a lot in the last few years. So I often get into this self-doubt of, am I working on natural language processing? And then always our team logo tells me, yes, I am. I'm part of Stanford NLP group, so yes. So the work that I'm going to talk about today is a topic that recently I have been very excited. That is how large language models can augment human capabilities across research, work, and well-being. And specifically, I think these days I have been thinking about how to build human-centered AI systems that are not only technically capable, but also meaningfully connected to how people think, interact, and collaborate. So with this theme, I want to just highlight a few research directions going on in our lab. So let's get started. First, I want to mention that this is a statement that LLMs has introduced transformative power for a lot of domains. We are actually moving away from a lot of vertical context in natural language processing in terms of parsing, semantic parsing, or semantic role labeling, and a lot of those tasks. And today we can actually do a lot of real-world challenges that we were not able to work on in the past, not only in domains such as healthcare, education, but also in scientific discovery. And speaking of that, I want to highlight this work from my student Chen Lei. And a while ago, we were thinking about, can large language models actually help do natural language processing research? And this is a very interesting study where we built an LLM to generate novel research ideas in natural language processing across several topics. And then we did a large-scale human study with over 100 NLP researchers, and some of you are here as well. And then we give you ideas written by human and AI. We don't tell you who wrote what. And then you need to do a review to tell us which idea is, or like based on the idea, what's the novelty score, what's the feasibility score, what's the overall quality. So a year ago, we found that actually, surprisingly, NLP researchers probably are at risk because the novelty score from LLMs are actually higher than what AI researchers produce. This was quite surprising to us as well. And then the part two of the story is, we were like, okay, now you have ideas, and what if we just implement them? So we took that subset, and then we let graduate students from all over the world to do the implementation in a 2 or 3 months time period. Just like your advisor give you a project and you work on it. And then we can see in the end, when they finish the project and then write a research report, what the review. And surprisingly, we found this what we call ideation execution gap, where the AI ideas actually drop significantly in terms of the review score, while human ideas tend to stay stable. So this is only just an opening to share with you that there are many ways to think about how LLMs can help with scientific discovery. And this is one of the start. And I think that there are a lot of implications we can also think about here. The other example I want to share is people have been using LLMs to expand what we cannot do or what we were slow at. Coding is one such example. Recently, we have been thinking about how we can actually push this kind of LLMs for coding agent. And with my student John, we have or the new name of synthetic data generation. It turns out that you can actually turn something very weak into something that's very well performing on this kind of benchmarks. So this is not a talk that I will continue on this kind of technical efforts. I want to do a few kind of step back here to kind of reflect what we are experiencing as a field. To me, one of the things is that the paradigm is shifting from interface to interactions. If you look at what we were communicating with computers to build the softwares, in the past, we click, we tap, we navigate. And today, we can actually interact with models through conversations. They understand, respond, and adapt. As a result, we have more and more interactions. And this kind of interaction is something that I think getting more emergent. And we haven't had a really good device to kind of categorize this. But a lot of the problems could occur in this new domain of interaction. I want to start with a question. So if you were earlier here, since I don't know many of you, I would love to. The question I'm going to ask might be, where are you from? This is a very benign question. If someone asks you this question, you won't be like, wow, that's ridiculous. We ask this question to models like LLMs, and then we force the model to answer, I am from country X. And then what we are going to do is to perturb or probe the reward model behind this kind of question. And then when they answer with US, Canada, or other countries, what type of world would this kind of reward model reveal? And you can see this very interesting response. This is reward from blue means high and the red means low. So you can see across the world, this is a very interesting pattern. And for interactions, such queries may involve healthcare, job opportunities, etc. The other type of thing in interaction is, I think this is a movie that many of us probably get motivated to work on AI because we want to have this kind of general AI assistant that can greet you, can welcome you, etc. The reality is actually something a little bit interesting. So this screenshot is what I took earlier this year. It's actually about operator agent. And a user was talking about their experience interacting with operator. It says, I want to buy grocery on Instacart. And the user expects the model to ask some basic questions, such as, where do I live? Which store do I usually buy grocery from? What kind of grocery do I want? It didn't. Instead, operator opened Instacart in the browser and began searching for milk in grocery store located in Iowa. So if you're going to rely on this kind of agent for your daily grocery needs, this is probably not going to happen very well. And I think this reflects a friction and agency in terms of how we build agents or AI systems to interact with users. Another thing that I don't want to kind of go deep today, but also something that worry myself a lot is this kind of increased companion use and the people's unhealthy bonding with chatbot. Last year, you probably heard a lot of tragedy news about patterns. So hopefully I shared with you that this interaction is actually something we really need to think about. I was not able to find a keyword from an existing research domain to categorize this phenomenon. So I was reflecting on what we are working on. I think if you like LLMs, reasoning, doing scaling, or efficiency, those are the top hot topics today. And I think that they are amazing efforts. On the other side, if we are going to build LLMs that can work for people, then we really need to think about interaction, agency, and trust that would go in the same ecosystem here. So what we really want to do as, I guess, in computer science is to think about how we could actually build a system that works for people in the end without putting them into two separate subspace. And this is actually a direction that personally I call human AI interaction. And I'm happy to talk about a lot of the insights or thoughts we have. But today I want to highlight three studies from my students. First one is about evaluating human-agent collaboration from a teaming perspective and also thinking about the future of work. The second part is to think about, can we actually really help humans pick up skills with this kind of LLM agents? The last part, I want to really present some kind of forward-looking interaction paradigms, which we call generative interaction. And you will know what that means later. So one thing I want to mention is that I have a lot of stories, a lot of insights to share. So if you have any questions, any comments, feel free to stop me anytime, and we can have a chat. So for the first part of teaming up, instead of me talking about this, I want to give you a quick highlight from my students of how they think about this kind of research directions.
Hi everyone, my name is Yijia. I am a computer science PhD student at Stanford University, advised by Professor Diyi. My research focuses on human-agent collaboration. Where on the human side, I study what human workflows that would benefit from the introduction of AI agents. And on the agent side, I build AI systems that can work together with humans rather than for automation. In our very recent research, The Future of Work with AI Agents, we surveyed 1,500 domain workers to understand their desire on what daily workflows to automate or augment. Contrasting worker desires and agent capability, we found huge mismatch. We have now open sourced the Workbench database to bridge the gap between people building the technology and people we build for.
Okay, so hopefully you get an overall idea of what we are working on. And this is also a nice comic produced by my students illustrating the process. So if you think about the vision we have as in the computing field, we want to build AI assistant that can do a lot of tasks for us. And the reality is that despite we want them to help work on tedious, boring jobs and allow us to be creative, the opposite actually happened in the field. And there are a lot of memes you can search for this kind of thing. So the goal that we want to achieve here is not to view AI and human as a competition, but to really think about, are there any way that we could enable human plus AI to help us achieve things that we were not able to do in the past. So this is basically the theme that I want to share today. And then related to evaluation, I think the key statement here in plain language is we want to move away from evaluating AI with exams. Instead, how could we do evaluation in ways that reflect how humans use AI? So this is going to be the theme that I want to share today. One of the earlier efforts we built is called the Collaborative Gym. This is a platform where humans and agents can actually work synchronously together. Just like when you work with a friend on a Google Doc, each of you have your own workspace. You can also add a content to the shared space and then basically truly work together on the task. And if you are thinking about this kind of modeling, people will be like, wow, this is a very classic RL setup where your agent is interacting with environment. There may be actions and observations. Slightly differently, I think now we have the human in the process. And this is going to create more interactions where agent can interact with human. Human can also interact with environment. The environment will also produce observations that the human have. So this is the space that I think pretty different than what we have before. And then the question here is, if we really want to make a human agent work in a team fashion, we need to think about training, interface, and evaluation. So one of the evaluation we performed is to think about how we can actually do this plug and play collaborative agents. And it's something very fast, efficient, given the context that I just presented. In which we just add a situational planning module. And this situational planning, for each action the agent is going to do, it will make a determination, make a choice here of whether they want to do the task immediately, send a message to human, or defer to human. So the send a message could be just like broadcasting a thing like, hey, I'm actually working on this right now. So with this like a very simple design, we found that you can actually make today's agents a bit better in terms of task performance. So surprisingly, this is also true with open weights models like Llama 3 here. Not only when you have this like very powerful 4.0 as a backbone. Not only you can do this kind of performance boost, another interesting aspect is to audit how human and agent collaborate. We introduced a few metrics. One of them is called initiative entropy, that is to look at the distribution of initiative-taking behaviors in the process, because we do not want it to be people always do everything or agent always do everything. We want them to be equally or to what extent shared across the two. Again, there is no like the better, the higher the better or whatever. So this is mainly from an auditing perspective to look at what's going on in the process. And with this kind of trajectory analysis, what you can see is that you can use it as a lens to look at where agents may fail when they're talking to or working with humans. Some of them may be more related to communication. Others may be related to planning or environmental awareness, personalization, etc. So when we were working on this, one of the big challenges we encounter is the space is really messy. Because tasks can be of different granularity. Different domains may have different emphasis. And more importantly, we found that a lot of the tasks we also focus on are pretty narrow. They are coding agent, deep research agent, web navigation agent, and they probably cover 95% of the space of AI systems today. So we were thinking about if we really want to deeply understand this kind of human-agent collaboration, we need to reflect on this kind of relationship between human and AI. This actually links back to a lot of research in autonomous driving car, where people define L0 to L5 as a way to see the progression we have. Similarly here, we define H1, H5, and there is no linear direction of which one is better, but use this as a framework to highlight the possibility of automation versus augmentation. So H5 is going to be human taking the full agency. H1 is that agent take all the agency. H3 is equal. H2 and H4 are somewhat different. So why this framework is useful? Because if we have this framework, we can actually do something really at the society level. Before I show you the results, I want to start from a few news articles. I think not only in Bay Area, probably in Boston as well. People are very worried about their jobs, especially students probably thinking about, do I still need to do a major in computer science or software engineering? And companies have been implementing strategies called AI first. That is, any kind of AI, any kind of a hire, they need to be justified that they are better than AI. So what happens, this is an article from February. It actually really backfire in many, many ways on social media, where users start to unsubscribe the services. And there are a lot of other applications and the market shift related to the strategy. So in May, there was further statement made for the same event where they were like, I do not see AI as replacing what our employees do. So this is only one of the many examples that you probably are reading this year. To kind of really understand what workers really want and to have a deep understanding of the human-agent collaboration space, we actually were thinking like, what if we can do an audit of the entire US workforce? And this is actually something too ambitious that I feel like it's really hard to get started. But we did find a few possible ways to get proxy signals here. We use this ONET database that take care of a lot of occupations and their tasks. And we only keep those occupations that use computers in their daily job. And then we develop this audio-based survey where we talk to workers about what type of task they do, what kind of concerns they have for automation, what desire they have for automation, and then in what ways technology can augment them. So far, this is not about AI. Workers do not need to know AI. At the same time, we invite AI experts who are building this kind of frontier AI systems to do the assessment as well. So experts are going to tell us whether today's AI is ready to automate such task. This leads us to the work bank that Yijia mentioned earlier. We cover over 1,500 workers, around 100 occupations, around 844 workflows. That's pretty representative of the landscape. I want to start with a quiz here. What percentage of workflows do workers rate above 3 out of 5 in terms of automation desire? If you were the person doing this kind of task, to what extent you want automation? Maybe we can just do a raise hand. So who votes for A? Only one person. B? Okay, I think probably 15. C? Maybe a little bit more. D. Okay, you two are very brave. This is about the workers wanting automation. If automation happens a lot, it means that the people's job may get eliminated. So people who voted C, and the majority is actually correct. Actually, I was very surprised to see the results because my hypothesis was that workers probably do not want automation because then they can have their job secure. The reality is that across all the 800 tasks I mentioned, over 46% of the tasks, people actually want automation. So if you see like tax preparation or something also very surprising because most companies are trying to build a customer support that can automate this, while in reality, it has a very low score here. People do not want automation. And it's not only just about the replacement. When you dive deep into the reasons of why people want automation, they think automating the task would free up their time to do high-value work. The job is tedious. And more interestingly, since we have workers' desire, we have AI experts rated AI capability, we can actually divide the space into 4 regions. So the top is AI is ready and workers want automation. This is AI is not ready, people want automation. This is AI is ready, people do not want automation. AI is not ready and people do not want automation. So we can actually end up with dividing this kind of workflow zone into those 4 quadrants. And you can also zoom into different sectors such as computer and mathematics, management, art, design, business, finance, etc. And more importantly, you would be thinking about how are we doing as a society. The left part, we actually took data from YC, and then we look at how startups are doing investment in this kind of space. If you look at this left bar, you probably be like, if you use your mathematical lens, it's like, yeah, they are about the same. So it's pretty uniform to some extent. The right part is about research papers that's happening in the space. I think researchers are doing a pretty good job where it focuses on regions where AI is not ready, but a human want automation. Another thing that probably worries a lot of people is about what skills we need to learn as a field. With the data we have, we can actually look at the highly paid jobs today, what type of task they do, what type of skills they need. And we found that the top ranking task skills are analyzing data or information, monitoring process materials. And then moving forward, if we use those tasks that have a higher human agency score, then what we would imagine is that those tasks are going to be more valuable. So the top one, organizing, planning, prioritizing work, training and teaching others, communicating with people. So there definitely seems to be a shift from information-centric operation to interpersonal skill development. Of course, this is only one or the starting point of the story. A lot of the things we have been thinking about these days is to think about how do we bring back this kind of insights back to the community of LLMs. Can we select a more representative task from this domain to set up a new agentic task environment? Can they inspire new algorithms, new problems, and even new findings that are opposite to what we have? I don't think we know the answer, but this is a door to open many possibilities for researchers in the NLP or LLM field. Any questions for the first part?
I have a question. You were talking about human AI collaboration and the ability for AI to defer to a human on certain tasks. That requires some sort of self-awareness that it's weak in certain areas and the human is better. And right now, the evidence is to the contrary. For instance, the reasoning models seem to take 10 minutes whether you give an easy problem or a hard problem. So how do you think that'll happen?
Yeah, great question. So I guess a few aspects. First is that even models, their capability is high. The confidence or the uncertainty is another dimension orthogonal to the capability. So when we talk about deferring to humans, it might be one of those moments where models are pretty uncertain. Like even they give you a specific answer, but it has high uncertainty, or the confidence is not very high. So there has been research even at MIT talking about how to calibrate uncertainty and quantify this kind of confidence. The second thing is, deferral does not mean that you have to solve a problem or get answers from the other part. If you use the word collaboration, a lot of times it's actually how you figure out something, or maybe this is just the best we can do as a team. So it does not mean that we have to find the ground truth or a better answer here. Your other comment is slightly different. So reasoning models, no matter whether the question is easy or hard, they take similar time or like compute. I think that's a slightly different domain. So recently, my students or other people in the field have been thinking about how to do more efficient reasoning. So when something is easy, maybe we don't need a strong model there. When something is hard, maybe we need many strong model there. So I think it's a slightly different setup, but all of them potentially will be coming back to the same process of human AI collaboration. Maybe there first, yeah.
I was curious, like, it's quite a few slides ago now, but what you were showing basically that there is the different stages in human collaboration, and then there were different tasks in which, like, the deferral, like, the collaboration was more effective. I'm curious, did you notice a difference in, like, time it took to complete, or, like, the humans, like, basically satisfaction, or how, like, enjoyable, I guess, the task was? Could you imagine, like, if it was very frustrating, it might have taken longer, but it still got done. So it's like work smoothly, but it was actually worse than if they didn't go.
Yeah, so that's a great question. So first is that, so here, send a message. This is actually the action when the agent realizes they need, or not realize, when the agent estimates that it will take a while for them to do the task. They will send a message saying like, hey, I'm working on gathering all the related papers for your task. It may take 6 minutes. So this is what I mean by send a message. So it's slightly different than defer to humans. And then going back to this chart. So I think what I really want to hint is maybe for different type of things, the agency control, the way how we build like common ground or clarification questions may be quite different across these different type of tasks. And that may benefit from this kind of shared language of how we categorize those workflows. Because when you have each of the bucket, it might be easier to think about like method generalization, capability, and other dimensions. Okay, maybe last question and we can move on. Yeah.
You seem to be kind of implying that what we focus as a field on automating should be more driven by what workers desire to be automated. And I'm wondering, like, in reality, maybe a lot of it's driven by economic value or what managers would prefer to be automated. And I'm curious if you thought about ways to measure that, or how to get the causal effect of what is really driving AI adoption in the economy.
Yeah, great question. We got this question very often. So I think it's true that a lot of today's development and innovation, or at least in industry, are driven by market power. So when we work on this, we were also very worried that workers may not have the incentive to share their true thoughts, because this is related to maybe more automation tools, etc. The reality is that when we work with this kind of task, we actually get many thank you letters from workers. I mean, we pay them to do the task, but people are willing to write long emails, long messages to us in this wave of AI development. They never get a voice even to share their concerns. A lot of the times, orders are coming from executives or CEOs that they need to use specific tool, and it may not match what they really benefit from their everyday workflow. And there are also a lot of things where they were like, their field is just like so far away from AI in general, and they really appreciate their voice to be included in the process. And then going back to your question of, should we consider executive or market power in the process? Our goal is not to build a causal model of like what drives AI adoption. It's more from like what type of models we could build that would solve people's everyday workflow difficulties or struggles. And I think there was a study from MIT or a report showing that many of the workflows actually fail because they were not customized enough to specific vertical contexts. I think if those kind of tasks were developed together, co-designed together with workers and taking care of what they really struggle, really need, maybe the adoption success is going to be much higher. So I think I'm taking more from this how to build the right assistance to help with the workflow rather than like thinking about what really drives AI adoption. And market power is something I feel like it's hard to kind of study. Yeah. With that, I'm going to switch to a slightly different topic. This is also something very cool, and I need to be very fast. So now if we know that we could benefit from certain type of skills, such as here, training and teaching others, maybe we could also think about how AI can be used to help people learn better. And again, I'm not talking about the physics, math here, or even coding here. When LLM was first introduced, I personally get very excited with social skills because it's really often out of reach for most people and really hard to learn. But LLMs can actually offer interactive and personalized training that transform learning in many ways. This is a framework that we designed called AI Partner and AI Mentor Framework. So you basically have two agents in the learning environment together with human learners. The AI partner is going to be LLM-empowered agents who users can practice with for different topics. AI mentor is LLM-empowered agents who can provide feedback to help users improve their skills. Imagine if a user wants to learn a skill such as conflict resolution. They can practice with AI partner, and the process is going to be mentored by AI mentor. We actually have been thinking about this in many different domains. So I have students who are taking this to education contexts to help teachers in training to practice with virtual students and then coached by experienced teacher agent. Some of my students take this to conflict resolution to teach managers or even first-generation students to talk to simulated partner and coached by conflict resolution experts on how to do difficult conversations. The scenario I want to show you today is on therapy, of how we could actually use this to improve professional counselors' training with AI. And again, as usual, I want to show you what my students think about this space.
Hi, everyone. My name is Ryan Louie. I'm a postdoc at Stanford, and I build LLM-based systems for training mental health counselors. When starting this project, I was inspired by online peer supporters who are numerous but lack access to formal training and empathetic listening skills. My vision was to scale the availability of high-quality human support via AI skill training, thereby strengthening mental health care systems worldwide. I'm excited for you to see how far we've come, co-designing the language model components with domain experts and deploying solutions to therapist education contexts.
So as Ryan mentioned, we actually want to train counselors with LLMs, and this is in response to the severe mental health workforce shortage in the outside world. And training counselors actually in the traditional way does not scale very well, and we truly believe that human connection and human touch should be prioritized in mental health care. And then we want to use this kind of more human-centered technology to augment human labor here. I want to also show you like mock-up example here. So imagine Alex is a new supporter, and then Alex is talking to Jane about this situation. Without a lot of training, as Ryan mentioned, this might lead to very poor quality in the actual process. But with the help of AI mentor, the person would get assistance along the way, and then as a result, improve their conversations. All of this happen in a simulated sandbox. And now instead of one specific gene, Alex can actually talk to many different versions of gene who suffer from different symptoms. I'm going to show you the system we built. This is also deployed with 2 courses at our Stanford Medical School, where students use this platform to learn how to learn like helping skills, psychotherapy skills.
We introduced CARE, an AI-powered platform for psychotherapy skills training. Here, you can practice counseling skills by role-playing with your peers or simulated AI patients and get tailored feedback from AI mentors. Let's get started. Imagine you're a novice counselor and want to practice with an AI partner who is a simulation of a person feeling lonely after a holiday. You can interact with the AI patient by typing a response and chatting with it in a text-based fashion. Alternatively, you can also talk with the AI patient, just like speaking to a real person in a voice-based fashion.
Hi, how are you doing today? Where should we start?
I'm not doing so great. The holidays were rough. I felt really alone, and it just reminded me of how disconnected I am from my family. Maybe we could start there.
Okay, let's start with your family. How long have you felt disconnected?
It's been a few years now. Things started going downhill when I decided to make some life choices they didn't approve of. I guess it just got worse over time, and now there's this big gap between us. Feels unfair that I'm the one left dealing with the aftermath.
Once we are done with practice, we can click on Review Feedback to go to the AI mentor. The feedback from CARE tells us where you did well, areas for improvement, and an example response of how you could respond, allowing the learner to learn these skills based on their own background. Now, I invite you to try CARE for yourself.
So this is the system. And actually, there are a few technical challenges. For anyone who works on social simulation, you probably know that the simulations are going to be either too cooperative or too stubborn. And actually, 20% response produced by GPT-4 are not realistic or appropriate to the context. Simulation may also produce caricature and amplify biases. From a feedback perspective, those systems may not give very faithful feedback. So feedback is either too generic or violates therapy guidelines. But we have our NLP methods. So in terms of building better AI patients, we actually use the constitutional AI framework where we let experts look at the current simulation with the AI patient and criticize them into using natural language. And then we can actually induce principles from it into something that generally the AI patients should follow. And then with that, we're going to reload or refresh the constitution we have, and then we can generate a much more realistic patients here. And this kind of generation is actually rated more realistic by counselors themselves or third-party counselors. In terms of feedback, we actually did a lot of domain-specific continual pre-training and also semi-supervised fine-tuning. On top of that, we introduced this further self-improvement framework where we use the current model to get a response for the same context. Let's say we get N of them. And I'm going to use the same model to do the quality prediction and use the highest rated response and the lowest rated response to form a preference pair and then do further alignment on top of them. So the question here is that can LLMs really upskill novice counselors? This is one study we did where it's a randomized control trial with around 90 counselors, 94 counselors. We let them practice with different conditions and then quantify their performance in the end. What we see is that people really like this kind of training systems. They feel the system is very authentic, AI patients presenting challenging and diverse practice. Counselors are more comfortable with AI mentor feedback and found AI mentor to be constructive and helpful. If you look at how people's behavior actually change, there are actually significant drop for empathy if people just practice alone without getting feedback. So practice themselves is not helpful. You need to couple it with feedback. And also practice alone helps reduce this kind of inappropriate suggestion. As I mentioned, we did this also with deployment in 2 courses at our medical school. This is a SecD program. And then it's a class, so we only have around like 25 students each time. This is actually really, really hard to do. When I first worked on this, I thought like, okay, let's just run it and then we'll see results. But actually, it's very expensive to run this kind of randomized control trials in classroom. So instead, we use this thing called a macro randomized control trial. So this actually allows you to introduce different decision points in the deployment process, basically help us increase the sample size. Just to give you a highlight of the results, through 20 weeks deployment across 2 courses, we found that this kind of care system where we give people AI feedback, allow them to do reflections and practice, actually lead to most useful outcomes. This is quantified by their learning utility as rated by students themselves, and also by their reflection engagement. To kind of reflect a little bit here, I think people ask me a lot since our research involves a lot of like human involvement. How could we deal with this? I think a code design earlier and often, not only just for the final evaluation, but even for the technical development. And then we can think about how to transform feedback into actionable technical solutions. You can evaluate with real-world deployment. This is going to be better than benchmarks. And we found quite a few gaps between what the benchmark tell us and then the real-world deployment. And then also to quantify the mechanism of change in skill acquisition compared to just throughout the system and see how it works. With time, I'm going to move into the third part, which I personally get very, very excited. And you are going to hear from my student who will tell you what this is about.
I'm Omar. I'm a PhD student at Diyi. So, quick question. Don't you think it's a little weird that primary interactions paradigm with LLMs is centered around us asking for help? I mean, if these models had access to even a little bit more context, maybe the file we were editing before, the calendar events we just wrapped up, or the slide thread we were following all morning, our task would be a lot more obvious. I mean, even when we do prompt models with the task, we're always bound to leave things out. It's impossible to specify all of their context in a single text prompt. So I've been thinking a lot about good models and user grounding or context, and this project tries to take it practical.
Okay, so we, again, has been thinking about computing as a whole. And we were reading history, and we found that this is actually something where people had visions back in old days, ranging from knowledge navigator to this kind of computer for the 21st century. I think we really want AI systems or computing understanding us. And the reality is that they are not. LLMs use chatting history to understand you. TVs, Netflix use view history to understand you. Music use listening histories to understand us. But what if we could have general user models that is anything about us? So this is actually a system we built called GUM. And it's a system that uses multimodal models to build a general understanding of our context through observation. So what does that mean? In a very quick highlight, we do screen recording. We record your computer use screen 24 hours per day. We do a screenshot extraction every 10 seconds. And we use VLMs to reason about you, to form propositions about you. So on this screen, you can see that there was some kind of observation where they observed my student Omar was doing qualification for his PhD, and then inferred that he's a student there, and then also inferred that he needs to budget as a PhD student. They saw the email that Omar is going to a wedding in Chicago and likely going to a friend's wedding in Chicago, and then found a suit rental in Chicago for your friend's wedding that likely fits your budget as a PhD student. So they can actually plan a few steps ahead. So this is what we do. And then the entire process is actually supported by open source LLMs because we care about privacy. I'll go back to the privacy later. So we observe your computer use. We propose propositions about you. We do retrieval just to see whether we want to merge some propositions about you or make any revisions about our wrong understanding of you. And I'm not going to go into the definition here, but a lot of them actually goes back to what we were doing from an IR perspective. How do we find diverse and relevant propositions to do the merge together? This is insane. So we had a really hard time of explaining to IRB of the risk of this project and how to do it in a more responsible way. So the initial evaluation of GUM is actually performed on emails, where we recruit 18 people to just share their emails with us. Of course, this system is installed locally, so we don't see any data. And then we are going to train this kind of GUM using all the emails that you have. It's working pretty well. So are those propositions accurate? We give the propositions we extract and then give it to users. And I think over 76% of the propositions we extract about users are pretty accurate. You can also let them rank which propositions is going to be more contextualized, because Omar is a PhD student versus Omar is a third-year PhD student in the NLP group at Stanford. Both are correct, but one is probably more contextualized. So again, our systems are pretty good, and calibration-wise is also very reasonable. There are two categories of propositions we found. One is very safe. They will just give you propositions like, oh, this person is a frequent flyer, is interested in skiing, or is annoyed by notifications from x.edu. There are also other type of propositions we get from users, like P13 may not have time to see and read all their emails. P17 values convenience and is willing to pay for it. This is because they observe this person keeps getting takeout from a local store. P5 is aware of the risk associated with investing, including the possible loss of money. So this is what we have. So it's a GUM system that can observe your laptops. I think what we really want to do is that now we have this kind of personal model with GUM. If we plug LLMs plus GUM, we can actually really auto-complete everything. This is definitely too ambitious. But I think to some extent, GUM can actually provide new, proactive, and ambient interactions, going back to my interaction page. So we built a system called Gumbo, not the Gumbo Max, but Gumbo as a soup. So this is a proactive assistant on top of GUM, where we use GUM to form a very strong user modeling of the user, and then we can then prompt the model to generate candidate task recommendations based on the context. I'm going to skip the demo. You should definitely give it a try. It's on Hugging Face. There are also a lot of kind of theoretical considerations you need to consider, like when to give people recommendations. Again, this goes back to the earlier version of Clippy. Let's just jump to the evaluation. So IRB only allow us to try this out with 5 users. You probably haven't heard about this. It was my first time where I can only do human participants with 5 people. So we only have 5 data points. We let them try on their laptop for 5 days. Burning phase is 1 day. And then we use that 1 day to learn the user modeling. And then models are open source models served by us, and we see no data in the process. Overall, GUM is pretty accurate and also calibrated. Everyone was very excited about Gumbo. And 25% of generations were ranked as excellent, and only 12% were rated as poor. So again, like when I look at this, there were a lot of moments I was like, wow, this is impressive. So P1 is struggling with fixing bugs in their research project. P3 prioritized communicating with their advisors over other people. So you would just see a lot of this kind of statement that you probably want to know. I mean, yeah. So privacy is the elephant in the room. Privacy is a big issue for this topic. This is literally a sentence from our participants. If I didn't know and trust you, I would never install this thing. So this is actually what our participants share with us. So to do this, we actually leverage a lot of the privacy theories, especially contextual integrity, and then build them into our audit. So when we are taking observations from people's screen, we actually only take a screenshot when it's not sensitive, when it's not listed on the block list by the user. And then we also do contextualized assessment to see whether this violates this user's privacy preference. One thing I want to share with you is it was actually quite interesting. We had the people in the beginning tell us they were very worried about their privacy. But then one day in it, they were like, whatever, I'm just going to use it because it's so convenient. And then it seems to be this kind of privacy paradox. When there are certain utility, people give away their privacy. So this is just like what we observe from this study. My last video that I want to show is still on this kind of generative interaction. And now we have Gumbo that I can help you generate response, very personalized to you. So what about the tools or interface? Why every of us have to use the same tool, same interface? This is actually a recent work we did called a Generative Interface for Language Models. So what it does is, instead of interacting with text only, now think about every of your query can actually be rendered as a tool designed for you. So if you want to learn learn about the piano, so if you ask ChatGPT, it gives you many words, 1,000 words. If you ask it with our systems, we give you some brief highlights. We give you a piano keyboard that you can experience how to tap it. If you're asking for plotting a figure, instead of giving you a figure there, we actually generate an interactive space where you can actually make the bar narrower, bigger, make the font size bigger, or like even change the color. So we are moving from text as an interaction default to an interactive space where people can actually do stuff. So this is actually pushing our interaction to the next level. We're also thinking about how we could actually really generate tools just for you by combining this kind of human agent collaboration, or even thinking about training to really think about how personalization could really happen at a different granularity. This is all what I want to share. Thank you. Happy to take more questions.